So let us start. Whiteboard is visible or not?
Yes, sir.
Okay.
Visible,
So,
sir.
okay. So let us start today's lecture. Now, we have seen already that suppose it is a L2 switch and we have got an access point here, AP1, and another access point, AP2. So suppose there are two nodes, M1 and M2, and there are again two nodes, M3 and M4. This is the situation. This is the L2 switch. This is wireless access point 1, wireless access point 2. Now, if you, and these are communicating also, means this switch has already learned the existence of these devices. Now, if I want to draw the MAC table of the switch, so suppose this is port number 1 and this is port number 2. So this is port, MAC address, and TTL. This is how our switches MAC table is. So in the current situation, what would be the entries in the MAC table? Anybody can tell. With port number 1,
MAC address of H1 and H2 both.
M1 and M2.
Sorry.
MAC of M1 and M2. And at port number 2, MAC of M3 and M4. This would be the situation. Now suppose M3 moves and joined under this, and M2 moves and joined under AP2. This can happen because if these are mobile nodes, you keep on changing the access points also. Suppose this happens, then what will happen? Switch will again learn that now M3 is under port number 1 and M2 is in under port number 2. So this is the working of intra-station switch. There is no new thing here. Any problems here?
No, sir.
No issues here. So this is known as layer 2 mobility, means uh, you are moving from one access point to another access point, and accordingly L2 switch is able to learn the existence or the location of the mobile nodes, and accordingly layer 2 switch will change the entries in the MAC table. This is as similar to, like suppose we have got port number 3 and 4 and two wired nodes are connected, say H1 and H2. So port number 3 and 4 would be having MAC address of H1 and H2. And suppose you interchange these location. Fine. H1 you connect to port number 4 and H2 you connect to port number 3. What will happen? After some time, L2 will learn that now port number 3 is connected to H2 and port number 4 is connected to H1. Any problems in this? Now let's see another situation. Suppose I say that there is a router and this router is connected to a L2 switch, and here again it is connected to a L2 switch. A router, or it can be a L3 switch. This L2 is connected with one access point, AP1, and this is connected with another access point, AP2. There's a node, M1, which is currently associated with AP1. Now, suppose this M1 moves and get associated with AP2. M1 get associated with AP2. Means M1 is moving from the range of AP1 and getting connected to AP2. Now think over it. What are the possible challenges? Think for 2-3 minutes and then answer. Anybody?
The other switch will never know that someone has joined until and unless the device tells it from or something like that. Like,
No, M1 will be in any case sending some message that switch will learn.
okay, if switch will learn, then there should not be an issue. L3 switch will only have will also have a table with the next hop, right? But
Think over it, Priyav, properly. Why we have to have a L3 switch? Why we have L3 switches or routers in the network?
okay, the connect M1 is now in the same local network, but the router will route it outside. That,
What are you saying? This is another subnet, no?
yes, sir. So, sir, if M1
And
moves to the
this is
L2
another
subnet,
subnet. And that's why you, you need to connect different networks and then you require a layer 3 device.
yes,
So this is another subnet. If it is a subnet, this subnet is going to have range of IP addresses which can be assigned. Yes or no?
yes,
And this would be having its own range. Remember the exercises we have done in the previous class? The valid IP addresses, the gateway address, default gateway. Remember or not?
yes, a new IP will have to be assigned.
Now, once this node M1 moves, which currently is having IP addresses from this subnet range, moves outside this subnet and joins to another subnet, can it keep its own IP address? Because M1 is having an IP address which is actually not valid in this subnet. It's not valid. So M1 need to get another IP address. Yes or no?
Yes,
M1 need to get another IP address. And if M1 get another IP address, what's the problem?
So there can be two problems. One is like probably a free IP might not be available.
Suppose that is there.
Conflicting IP address. Already an IP is there with that or something like that.
Suppose there are a lot of IP addresses. No problem.
But then like will the earlier like previous IP be forgotten automatically?
I don't know. I'm just asking it. So you are saying you only said that if M1 moves out and joins to under AP2, which is in another subnet, M1 need to get another IP to remain valid in that next subnet. But if you provide it another IP, what would the other problems?
Not sure.
Hmm?
Not sure.
If you remember, not you people have forgotten everything about networking. When you are running a network application, suppose M1 is a client, say M1 is running a browser, right? And it is connected to some server, say web server. So M1 would have opened a socket. And socket is bind with what? When you bind a socket,
Port.
you bind with it port
Port.
and
IP.
IP. So your client browser, your client M1 is a client machine which is running a browser. Fine, and browser is having a socket which is listening on receiving data on some port and some IP address. Got the point?
Yes.
And this download is going on or the streaming is going on. Now, if you change the IP address of M1 machine,
All the
this session,
connections.
this session is not going to be there. Got the point?
Yes, sir.
You have to open another socket, reconnect, and do all those kind of things. Is this point clear to everybody or not?
Yes.
Yes. So when you have mobility has got lots of effect on overall protocol stack. As we have seen, like if only you are changing the access point, but not changing the network, then only layer 2 switches has to change their MAC table. When you are changing a network from one network to another network, then you cannot keep your IP address, which is going to be invalid in the next network. And as soon as you change the IP address, you cannot keep those sessions running because you need to open another socket and do all those kind of things. Can you think of any other solution so that we can keep our IP address?
Sir, the way we validate the IP of a subnet can change.
Mm-hmm. Or you just do a small change in the routing table here and install a static route. that for this destination, you forward the packet from this interface. M1 has moved. M1 is having IP address. Means all the data which will come to M1 will be forwarded to this interface. As soon as you see the destination network, and then routing table, remember? Subnet mask and do all those things. Router will forward every packet for M1 from this interface. But you have a static route, whole complete IP address, fine, with slash 32. All the bits has to match, and put that entry and forward it, get it forwarded to this interface. Your work will be done. Yes or no?
Yes, sir.
Hmm?
But then how many static entries will be there? Like there will be a lot.
So your point is very true. In this case, somebody has to sit on this router forever because nodes are moving from here and there continuously, and you keep on doing that static route entries. Another situation is, suppose this M1 is a web server and M1 is moving and changing the networks. What will happen? It's not a
All
client
the
machine.
clients will be-
Huh?
all the clients need to
No,
get the
then you
connection.
need to do the changes in DNS all the time. Yes or no?
Oh yes, sir.
Because your IP address is changing continuously.
Yes, sir. Sir,
So you need to
we can do one thing. Can we like we do in the DNS A route? Like we can just assign one IP to another IP or forward something like that.
so you have to have some fellow sitting on DNS because there
Oh,
will be a
okay.
lot of nodes, mobile nodes, which are moving.
And not on the DNS. I am thinking if we can do something like that on the. No, it's the same thing. Static route. Okay.
So you got the problem or not, everybody? The mobility is problematic as soon as we have layer 3 mobility. When we allow mobile nodes to cross the boundary of the network and join another network. If you don't change IP address, lot of it is very much cumbersome. If we change the IP address, then sessions would be
Well,
invalid. Sessions would be broken. So this is the issue which we are going to discuss today. After getting the details, let's see how we can handle this. So we are discussing here the network layer mobility. So our focus is at the network layer, how we can handle the mobility. Routing, finding a path from source to destination. If you keep on maintaining your IP address, you need to do frequent route changes, routing table changes due to the host movement, and which may lead to some troubles. What is the goal? Goal is to decrease the routing related overhead and find the shortest route, find a stable route despite mobility. As I have already discussed, if you talk about traditional routing, it is based on IP address, and network part of IP address determines the subnet. If you change the subnet, you need to change the IP address, or you need to maintain spatial routing entries to forward the packet to new subnet. And both of them are having problems. Now, generally what you do in your home or anywhere in the Wi-Fi network, what you do is you use DHCP. It is very prevalent in wireless network. When a node joins, it sends a DHCP request. Remember the DHCP process, whole process, and gets an IP address. Now this DHCP, where this DHCP server is running, that is interesting. If you have purchased a cheap AP access point like D-Link and whatever you purchase and hook it to your WAN side of your hostel. So what is happening there in the access point itself? Please be very careful. This is important. In access point itself, we have DHCP server. And once you configure the access point, you give the range of IP address. So your access point, the cheap access point, is running a DHCP server. So what you do, you take your access point, you take the LAN part and connect to your hostel IO port and provide the LAN part IP address, our institute IP address 172.31.x.x. This access point AP is running a DHCP server. Now, when you connect your mobile phone or your laptop, you run a DHCP request, you get an offer, you confirm that, acknowledge, and then you get an IP address. And that IP address, if you have seen, you get 192.168.x.x. Am I right? The whole configuration is okay? Pranav? Priyav?
Yes, sir.
This is what you do? You take your access
Yes, sir.
point, you connect your LAN cable to the port, IO port of your room. You assign the IP address of your room to this part of the access point. Then you configure your access point and your laptop gets 192.168.x.x. So here the DHCP server is running at your access point.
Yes, sir.
Now the problem is 192.168 is not valid because our network is 172.31. Our infrastructure switches and routers understand this. What is getting done? Yeah, Priya.
Sir, simply our IP, all the IP addresses connected to this are routed through 172.30.
How?
The source is changed. Source IP.
How? इसीलिए नौकरियां नहीं लग रही हैं. NAT. Remember?
NAT. Yes, sir. NAT.
Network address translation. Your this cheap access point also run a NAT logic.
Yes, sir.
And for this access point NAT, the public IP would be this, outer IP would be this 172.31.something.something, which is your LAN part. Okay. And whatever
Yes.
IP addresses you are getting 192.168 to your laptops and mobile phones, that would be NATed and your source IP address will be changed. Got the point, everybody?
Yes.
This is regarding our cheap access point. If you go to DJ hostels, DJ hostel, I'm taking the example of DJ hostel. I'm not taking the example of institute Wi-Fi, which are there in Patel, Raman, and other hostels. That is a very different. That is based on CAP-WAP, which we'll be discussing after the mid-sem examination. That's a different thing. But if you go to DJ hostel has got good quality access point from the institute. So what we have done, so there is no DSCP here. There is no netting here, nothing. So what we have done for whole hostel, we have installed a DSCP server. On different VLANs, we install our L2 switch here, a Cisco L2 switch in the control room. And we have divided whole hostel into different subnets, different VLANs. And for every VLAN, a DSCP server is running. So there, the laptops are getting the IP addresses from 172.31. So after this whole discussion, the central point remains same. If you change the network, if a mobile node moves across the network, IP address will change. And if IP is changing, sessions will be disconnected. You have to reconnect the sessions. Got the point, Priya?
Yes, sir.
So generally, quick solution is use, like I've discussed, use DSCP to have a new IP address as and when you when mobile device moves to a new subnet. But this new IP address may not be known to anyone. If it is a server, if a mobile node is running a server, then you need to change the DNS entries, which may take long time. As we have seen, because sockets are bound with the IP addresses, TCP connections are going to break, and obviously the security problem is there. If you don't change the IP address, as I have discussed, you have to change the entries in the routing tables. Change routing table entries as MN moves from mobile node moves from one network to another. But as you have already suggested that this will not scale because there would be a lot of mobile hosts and there would be frequent changes in the location, and obviously security problem is going to be there. What we need a solution which has to be compatible with the existing protocol stack. We don't want that we just provide a solution which force changes to applications and network protocol which are already in use. And it should also be downward compatible. It should not force to change the layer 2 level protocol. New protocol should be transparent to the higher layer. TCP should not get any idea. TCP should get an idea that mobile node is having its own IP address, the initial IP address. That should be transparent. The solution should be scalable, giving the mobility support to the mobile nodes. IP layer mobility support to mobile nodes should not generate too many messages and should provide scalability if there are a large number of mobile nodes. Obviously, there has to be security. The management messages should be authenticated. Now, these are the design issues before the designers, in front of designers, that these things has to be taken care of. So C.E. Perkins, this is a very popular name, who has given the concept of mobile IP, basic concept of mobile IP. And then afterwards, we have hierarchical mobile IP, proxy mobile IP, and there are so many concepts which are getting utilized nowadays. So let's see the concept of mobile IP. First of all, the terminology. Mobile node, a node which moves across networks but without changing its IP address. We don't want to change the IP address. We want to make it transparent to the higher layer. There's another node which is known as correspondent node. Correspondent node which is actually having a connection with the mobile node, TCP connection with the mobile node. Another term is home agent. It is typically a router in home network. Home network means the original network of the mobile node. We'll see the usage of home network and other. Foreign agent, again, typically a router. And this is a foreign agent. This is a foreign agent, a router in a foreign network, in which network the mobile node has arrived. And then there is another term known as care of address. Address which is given to mobile node for a while. So it is just like, the situation is like, situation is like this. Suppose I live in Allahabad, but for 15 days, I am in Kanpur. The next 10 days, I am in Ahmedabad. And I have told my office in Allahabad that between this date to this date, I would be in Kanpur and my current address is some hotel room number, something like this. When I moved to Ahmedabad, I've again informed my office back at home that I would be in Ahmedabad, some hotel and some room number. So for rest of the world, my address is Allahabad only. So whatever mails, snail mails I'm talking about, whatever dark is coming, is destined to me, would reach to Allahabad. Because this is my home network. Now Allahabad fellows will forward this because Allahabad fellows knows that for next 15 days I would be in Kanpur. So this letter will be forwarded to the my Kanpur location. Without letting my source know about anything. Source does not know where I am. Source has just thought that I have sent the letter to my address. You have informed your home network that, okay, I would be moving and I would be staying somewhere here for next 15 days. So this would be forwarded to your location. And if you change location, you keep on informing to the your home network, and the home network would be forwarding the mails to your current location without any knowledge to the correspondent node which is trying to communicate to you. This is the central idea behind the Charles Perkins solution for the mobile IP. So let's see the solution. Please be very careful. I'll go slow. This is important to understand. Say this is our home network, which I am part of this network, my permanent address, and my IP address is this 128.119.40/24. Permanent address in home network can always be used to reach the mobile. This is my home network, class C network, and this is my permanent address 128.119.40.186. In this router, the home agent is running. Entity that will perform mobility functions on behalf of mobile when mobile is in remote location. This is our internet. This is our correspondent node, which is trying to communicate to mobile node. Now, that was regarding our home network. And now let's see the foreign network. This is the visited network whose network prefix is this 79.129.13. This is a foreign agent is the router of the foreign network entity in visited network that performs mobility functions on behalf of mobile. Permanent address remained constant, which was 128 when mobile visited to the foreign network. Now mobile is in the foreign network. 128.119.40.186, that with the permanent address will remain constant. But currently, the mobile node gets a care of address of the visited network. So temporarily, वो होटल रूम का एड्रेस मिल गया उसको, that is 79.129.13.2. So this was regarding home network. Now this was regarding the foreign network and the care of address. पहले कुछ एड्रेस था, होम नेटवर्क, एवरीथिंग. जब वो मूव किया तो उसने अपने होम नेटवर्क को बताया कि मैं यहाँ जा रहा हूँ फॉरेन नेटवर्क में और मेरा केयर ऑफ एड्रेस ये है. क्लियर प्रिय?
Yes, sir.
Now just see how the things are going to happen. So the home network, visited network, internet in between. When mobile node moves, mobile contacts the foreign agent. ये कैसे पता चलता है कि फॉरेन नेटवर्क में आया, कैसे हुआ, ये भी बात करेंगे. When mobile moves out, it somehow contacts with the foreign agent. Foreign agent will contact with the home agent of the mobile network, mobile node, and informs, भाई ये तुम्हारा एक आदमी आया मेरे पास. Foreign agent contacts the home agent and informs that this mobile has arrived in my area and this is your mobile. End result is foreign agent knows about the mobile and home agent knows about the location of mobile. नोड बाहर गया, नेटवर्क के बाहर गया, उसको पता चला कि यार यार हम बाहर आ गए। कैसे पता चला? आई विल टेल यू लेटर। हमें अपने नेटवर्क में नहीं है, तो विल कॉन्टैक्ट टू द फॉरेन एजेंट। हाउ टू कॉन्टैक्ट द फॉरेन एजेंट, हाउ टू गेट द लोकेशन ऑफ फॉरेन एजेंट, अगेन विल डिस्कस. It will inform the foreign agent that I am from out. Foreign agent will inform back to its the home agent, home network कि तुम्हारा एक आदमी इधर आया, एक मोबाइल इधर आया. Now what will happen? Correspondent node, not knowing anything, will send the packet to mobile node, which will be routed towards the home network of mobile node. Because correspondent node knows the IP address of mobile node, which is its permanent address. What is that? We have seen that. Some 128.119. So correspondent node will send data towards the home network. Home network will forward the packet towards foreign network, because home network knows the location of the mobile node. Home agent intercepts the packet, forwards to the foreign agent. Foreign agent will receive the packets and forwards to the mobile node. And now, because mobile node knows the IP of correspondent, it can reply directly to the correspondent. So these are the 4 steps. सब डेटा तुम्हारे होम पे आएगा, होम वाला फॉरवर्ड कर देगा उसको फॉरेन नेटवर्क पे, फॉरेन नेटवर्क foreign agent will forward the data to the mobile node, and mobile node will now reply directly to the correspondent node. As we have discussed, mobile uses 2 addresses. Permanent address, which is its actual address, permanent address, which is known to the word. So correspondent node will be using this address only. Care of address would be the temporary address of the mobile node used by home agent to forward datagrams towards mobile. Foreign agent functions may be done by the mobile itself. We'll discuss it later. There may be a situation of triangular routing when both correspondent and mobile nodes are in same network. There would be a situation of triangular routing. We'll see that, don't worry. How the datagrams are forwarded, please be with me. That is important. How the datagrams would be forwarded. Suppose this is the situation. This is the permanent address of mobile node. क्लास में है गोयल साहब अभी? This is the permanent address. Correspondent node is sending packet to the destination using the mobile node's IP address 128.119.40.186 and the data. Now what home agent will be doing, because home agent knows कि मोबाइल अभी हमारे पास नहीं है, मोबाइल कहाँ है, मोबाइल का एड्रेस अभी क्या है, this is the care of address. There would be IP encapsulation. Tunneling. So the packet of correspondent node would be encapsulated by one more IP header where destination address would be of the care of address. Now using this destination address, data will be routed towards care of address, which is the address which has been given to mobile node in the foreign network. Now foreign agent will do what? Will remove the outer header and forwards the packet towards the mobile node. And node is not having any change of IP address. This is how things are getting done. Now suppose mobile user moves to another network. So it will register with new foreign agent. Home agent will keep on updating the care of addresses. And packets will be keep on forwarding to the new care of addresses. During mobility, even if you change 2 or 3 foreign networks, that will remain transparent because mobile node will not change its original IP address and all the sessions are going to be maintained. There's a small change in that. First step, correspondent request receives foreign address of the mobile. And now correspondent node can directly send packet towards the foreign agent. This is known as direct routing. And foreign agent can forward it to the mobile. And node can reply directly to the correspondent node. This is known as direct routing, where home agent informs about the location of the current location of the mobile node and correspondent node can directly transfer packet towards the mobile node care of address. There is a downside here that here now correspondent node knows that mobile has changed its location. It is not transparent to the correspondent node. But it will be able to solve the triangular routing problem. What is triangular routing? Let's see the triangular routing first. Suppose this is home network. This is foreign network 1 and there is foreign network 2. This is a foreign network. This is home network. Your correspondent node is here in this foreign network. And your mobile node also is in this foreign network. Now, if correspondent node wants to transfer packet to mobile node, correspondent node will send the packet to the home network. Home network will forward the packet to the mobile node. So see, this is triangular routing. Both mobile node and correspondent node in one network. Still, packets are getting transferred through the home network. If you have direct routing, the first condition, as soon as correspondent node sends the request to the home network will inform the current location of mobile node to the correspondent node, and now correspondent node can directly contact with the mobile node. So direct routing can solve the problem of triangular routing, but in that case, correspondent node will be aware about the location changing and the current location of the mobile node. Any confusions, Priya? As I told you, any confusions?
No, sir, it's clear.
It's clear. As I told you, it can overcome the triangular routing problem, but it is not transparent to the correspondent. Correspondent node must get care of address from the whole agent. Now, if mobile changes the network, again, there would be issue. The current foreign agent will become the home agent, and that home agent will inform about the new foreign network, and this keep on happening. Mobile IP is described in RFC 3344. We have seen many features already of mobile IP in our general discussion. Concept of home agent, foreign agent registration, care of address, encapsulation. But we need to understand these three mechanisms: how to discover the agent, how to do registry with the home agent, and how indirect routing will be performed of the datagrams. So we'll stop here. I suggest you to revise everything which we have discussed today, and tomorrow we'll be seeing the internal details of mobile IP, that how agent can be discovered, how packets can be transferred from one end to another end. If there are any questions, you can ask.
Sir, when the like mobile comes back to its home, at that point of time,
It
it
need to
will
deregister. It need to
yeah,
deregister. There are so many things which we need to discuss, which we'll be
okay.
discussing tomorrow. What about ARP?
Yes, sir.
Suppose somebody runs an ARP request for a mobile node which is not in your network. What will happen? Because it has
Correct.
moved away.
Hmm.
So what will happen to those ARP requests? If mobile node comes back, what will happen to the ARP caches of all the systems? There are so many things which remains to be discussed. We'll discuss tomorrow. Okay.
Got it.
Just
Got it.
think over it. Think over it. Whatever thing we have discussed, just try to draw it that, okay, how we can have encapsulation, how the tunneling can be there, what will the tunnel endpoints, uh, where the tunneling will happen, encapsulation will happen, where the decapsulation will happen, how things are getting done. That is what I want you to discuss among yourself and think, and then tomorrow we'll be taking in more detail.
Got it.
Okay. Any other question? If there are no question, we can stop. Thank you.
Thank you, sir.